Good morning, everyone. Our project comes under the Smart City domain, which focuses on using technology to improve the quality of urban life. When we think of smart cities, we usually imagine smart transport, renewable energy, and digital services. But one of the most critical aspects is waste management. During our field immersion, we observed how waste is currently handled. Most segregation of biodegradable and non biodegradable waste is done manually. This method has three big challenges. It is slow and inefficient because manual sorting can't keep up with the volume of urban waste. It is unsafe for workers as they are directly exposed to contaminated materials. It is error prone, which means recyclable items are often lost in landfills. Improper segregation increases landfill pressure, causes pollution, and directly harms the health of sanitation workers. This led us to frame our problem statement. How can we create a smarter, safer, and more efficient waste segregation process for cities? Our internship focused on finding an answer, and that's where we began our idea exploration.
Brainstorming and final concept. Once we identified the problem, we brainstormed different solutions. Here are some of the ideas we discussed. Introducing color coded bins to encourage segregation at the household level. Conducting awareness campaigns to educate citizens about proper waste disposal. Setting up a penalty system for incorrect waste disposal. Installing smart bins with sensors that identify waste type, and finally deploying AI powered segregation machines to automate the process. After evaluating all ideas, we chose the AI powered segregation system. Why? Because it does not just depend on human behavior, which can be unpredictable. It automates segregation, reducing workers' risk, and it offers scalability across multiple smart cities. Our concept uses AI with image recognition to identify waste type and a robotic arm to separate biodegradable from non biodegradable waste. This ensures accuracy, efficiency, and reduces health risks.
Technology mapping and feasibility. To make sure a solution was practical, we mapped it with available technologies. Here's how the system works. A camera module captures the image of the waste. An AI based image recognition model processes the image to identify if it is biodegradable or non biodegradable. A robotic arm powered by servo motors then separates the waste accordingly. A Raspberry Pi runs the model using open source AI tools. Now, let's talk about feasibility. The hardware required is affordable and widely available. The system requires only moderate technical skill to implement and maintain. It can start small, like in one municipal ward, and then scale across cities. Most importantly, it aligns with Sustainable Development Goals. SDG 11, Sustainable Cities, and SDG 12, Responsible Consumption and Production. This makes it not just a tech project, but a socially responsible one too.
Our design process also focused on empathy. We built the persona of the sanitation workers because they are the ones most affected. Here is the persona includes name or role, which is sanitation workers or officer. Employment, which is works daily in hazardous condition, manually handling mixed waste. Pain points: difficulty in segregating mixed waste, constant exposure to health risk, fear of losing jobs due to automations, physically exhausting, time consuming work. Desired gains: safer working conditions with less direct contact, tools that help rather than replace them, increased efficiency and dignity in their work, assurance of job security even with technology adoption. By mapping their pains and gains, we ensure a solution is not just technical but also human centered, aiming to empower workers rather than replace them.
Now let's see about societal and technical impact. Now that we have seen how the system works and how it connects to the needs of workers, let's step back and ask what difference will this actually make to society and technology? Because at the end of the day, any innovation is valuable only if it creates a positive impact. First of all, societal impact, health and safety. Today, sanitation workers come into direct contact with harmful waste, medical waste, and shop objects. This means fewer injuries, fewer diseases, and a healthier workforce. Second of all, cleaner cities. Better segregation means more materials get recycled and less waste ends up in landfills. Imagine a city where plastic bottles actually reach recycling plants instead of clogging drains. That's the kind of ripple effect we aim for. Third of all, dignity of labor. Today, waste picking is often seen as dirty work. By automating the most unsafe parts, we restore dignity, and workers become operators of smart machines, not people rummaging through garbage. At last, community responsibility. When people see smart systems in action, it encourages them to take waste disposal seriously. It fosters a culture of responsibility. Citizens start to segregate at source, and workers feel supported. Second of all, technical impact. Automation. AI and robotics mean the system can work continuously, unlike manual processes which are limited by time and human fatigue. High accuracy. AI image recognition ensures correct classification of waste, something that human eyes may miss, especially under unhygienic conditions. When it comes to efficiency, the system doesn't just segregate faster, it does so without breaks, errors, or risks. Over time, this increases recycling rates and reduces waste management costs for the city. Scalability. The system is not limited to one city. With modular hardware like Raspberry Pi and open source AI, it can be replicated across multiple smart cities, whether large metros or smaller municipalities.
To wrap up, our social internship was a journey of learning and applying knowledge to our real world problems. The key takeaways from our journey are: first, we understood the daily struggles faced by sanitation workers. Second, we saw how technology like AI and robotics can integrate with civic services. Third, we realized the importance of public behavior in waste management. Fourth, we practiced idea validation, starting with many concepts and finalizing the most impactful one. Fifth, we aligned our work with sustainable development goals. And finally, we gained teamwork, problem solving, and practical application skills. In short, this project was not just about waste segregation, it was about creating a vision for cleaner and smarter cities where technology and humanity work together. We believe this solution can be a starting point for larger smart city projects. To know more, you can scan the QR code on our poster and view our full video presentation. Thank you.